Hello there and welcome to the quick review of Module 7. So what we looked at was model-based testing. Creating a model gives a lot of insights, in fact deeper insights and understanding of the system. The moment the system is understood extremely well, it actually builds up tremendous amount of confidence in terms of how we are going to test it. Now confidence is not only just within the individual who is looking at it, but in terms of a systemic confidence that we would have got. The model-based testing also depends on choice of the model. Now there are various ways how one can model the system. And the accuracy with which it is modeled and the accuracy of the model itself will decide as to how adequate this particular model-based testing for a particular target system is. With so much of dependencies, definitely there is a lot of domain expertise as well as expertise of a test engineer will come into play. So typical sequence are you model the system, you identify the system behavior, its threads, transform these threads into test cases. So each of the threads could be, as we will see in the state machine, it could be the paths that we take care of. And then we execute the test cases and again we iterate based on what observations we have out of those test cases. Model-based testing can really add a lot of rigor and it's very advantageous when we are looking at certain kinds of systems. Now what are these executable models? Executable models are finite state machines, Petri net state charts. That is what we definitely will focus on in various modules. In this particular module, we are looking at finite state machine and extended finite state machine. So for a moment, let's also look at a few aspects of model-based testing and choice of model. So let's look at here, what do we have? The expressive capabilities of behavioral models. So what are the behavioral issues that we look at are over here? And I'm going to pick a couple of them for example. What we have is, say we would want a particular sequence. When it is a particular sequence, it's part of structured programming. We want to bring a sequence to the entire behavioral aspect that we are looking at, right? In terms of, say, if we take ATM, then it is entry of the pin to withdrawal would become a sequence. Or in fact, within the withdrawal structure that we have, if I'm going to now do a couple of withdrawals, then I need to make sure that the amount that I'm withdrawing every time allows me to do that. Another set is where we are looking at a lot of events. Suspend, activate, resume, pause. On a task piece where we are looking at a lot of concurrent execution that could happen. So I'm looking at a lot of concurrency that can happen, parallelism that could take place. And lastly, what we have here is context-sensitive inputs. Certain inputs that we consider would be different. So when I'm looking at pressing the enter key, in certain line edit and text edit, it would act very differently. Simplest case is that enter behaves differently when I punch in a URL in the address bar and click enter versus when I enter it in a box, which is a search box. It actually internally takes care of what is expected. First it really does the job of fetching the URL. The second one actually gets us the entire output of search. Now to make choices on the expressive capabilities, so each of these models have their own expressive capabilities for especially the behavior issues that we looked at. Decision tables form one of those least expressive, if I may say so, especially in the area where we are looking at the events. Whereas Petri nets, EDPNs and state chart will become extremely effective. Thus, knowing these tools, knowing these models is going to be very, very advantageous for not only the part of design, but also part of testing. because that is how you could model. And the moment modeling of a system is done, it is easier to derive the test cases. And not only easier to derive the test cases, it is also, in fact, possible to automate generation of test cases. So what we have here is a modeled system, and what we looked at was two parts of it, right? One is what the system is and what the system does. Structure versus behavior, and also what the system does. Those are the executable models that we looked at. Versus when I'm looking at components and the way I represent them in what the system is. Further, we did mention about generating the test cases automatically from the model. So the model provides us enough ways in which we could derive the test cases automatically. And we'll look at it from an example where, if you recollect from what we had seen in the module, we looked at constructing a graph out of a state machine, and after that it's traversal of the graph that will get us the test cases for a particular scenario. So we look at a finite state machine. Finite state machine is a method of expression of design, and we are modeling a state-based behavior. And compared to this, state charts provide a rich extension, and Petri nets also provide an expression for concurrency and timing. So then we look at also extended finite state machine, where the state machine allows us to add on more information in terms of condition and action. Along with such a model of how things work, we also need to consider the fault model. Fault model that will define a small set of possible fault types that can occur. And let's focus on FSM or EFSM to begin with. So the fault categories that we looked at were operations error, where we have got error generated especially upon transition, transfer error, incorrect state transition. So something happened, instead of going from state A to state B, it landed up from state A to state C. Extra state error or a missing state error. Now, extra state error may not be harmful, but missing state error can definitely be harmful, because then you're changing the system behavior altogether. We looked at some of these examples: the garage door, the building lighting control system, and elevator control system. In fact, some of these examples are what we continue to look at throughout the remaining modules as well. And last but not the least, again, the coffee tea vending machine, which accepts token or coin and also gives an option for sugar, is what we looked at. And we remember that we also understood that some of these transitions is what we need to correct. And our entire mechanism to bring test cases is all around states, transitions, and paths that get created. So very involved, very profound, and very useful technique of modeling, also considering faults and then building test cases with it. Model a system, it would be easier even to generate test cases automatically. Thank you.